This video walks through how to perform a conformational analysis on an amino acid in Spartan. So as you can see here, we have cysteine H2 positive modeled. We have a proton on the amine group and a proton on the carboxylic acid. First, notice the carbon-carbon backbone held together by two dihedral bonds. This is where our conformational analysis is going to pivot. So as you can see, we select a dihedral by selecting 4 molecules in a specific order. In the right-hand corner, I change the bond angle to 0 degrees. As you can see, the dihedral angle is 0 as it's all in one plane and still highlighted. So the next step is to lock in this dihedral. We can do that by going back to geometry and selecting constrained dihedral. Make sure you select the atoms in the exact same order as you did before. Notice the lock button in the bottom right. Click that and notice the name of your dihedral. It should say constraint 1 even though it says constraint 2 in this video. Be sure to check the profile box and set your range from 0 to 360 degrees. In this video, I selected 6 steps to make the calculations run faster, but you should aim for running 12 to 24. Now it's time to run our calculations. Change your calculation from equilibrium geometry to energy profile. Keep the rest of the settings as the defaults. Also notice the space that you're running your calculations in, whether it's gas or water. Also take note of the total charge. Make sure that you adjust it accordingly to your protonation state. While the calculations are running, I've opened up another model of cysteine to walk you through how to do the second dihedral. It's exactly the same process. We start by observing the second dihedral and specifically the order that I selected the atoms. Go to Geometry, Measure Dihedral, select the dihedral, noting the specific order, and set the angle to 0. Notice how the dihedral angle is set to 0. The next step is again to select Constrained Dihedral. Be sure to select the atoms in this dihedral in the exact same order. This is one of the most important steps in your conformational analysis. Note in the bottom right how I performed the exact same functions that I performed for the first dihedral. As you set up your conformational analysis for your specific amino acid, the most important thing you can do is keep track of your dihedrals and the order that you select your atoms. This will be incredibly important in going with your final conformational analysis. When your conformation is locked, run the exact same calculation settings. When your calculations are done, be sure to open and save your auxiliary files when prompted.